Hi everyone, we're gonna do now question 9 from this revision sheet we're looking at, and question 9 says explain how to find the speed, the distance and the acceleration from a velocity time graph. So here we have an example of a velocity time graph. It's always best to use examples and drawings to answer these questions. So let's say that's what happens on our graph, and let's say that this is 10, 20, 30 meters per second, and this is in seconds, and this is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, etc. Now, the first thing we were asked is how to find the speed. So how do we find the speed out of this graph? Well, this axis is telling us the speed at which this is moving at any one time. So as the time goes by, these are the seconds that go by, then we can ask the graph, hey, what's the speed after 1 second? So this would be after 1 second, so that's the speed. That's the speed. And then after 2 seconds, then that would be the speed. After 3 seconds, this would be the speed. After 4 seconds, that would be the speed. After 5 seconds, this would be the speed. So here you can see that the speed is not changing at all. In other words, this is a constant speed, and it's going at 30, more or less, 30 meters per second at a constant speed for between 2 seconds and 5 seconds. It's really not increasing in speed at all. While here, from 0 to 2 seconds, it's increasing speed very quickly. It goes from 0 to 30 meters per second in 2 seconds. So in other words, in order to find the speed, it's the easiest one. We just literally read off the y value. So we just read off the y value from the appropriate time. Okay, so what I mean there by appropriate is that the time where they ask us appropriate time, or the given time that they ask us. Okay, so if they ask us for, hey, what's the speed at after 3 seconds, then you say that, well, this is my time, so therefore it's 30. Okay, so the speed is easier, we just read it off. The distance in a velocity time graph is well, let's have a quick look at this, just so you see why. Imagine that there's a line here dropping down, just so we can see this properly. What's the formula for distance? Well, let me see. If speed has units of distance over time, then of meters per second, then the formula is always going to be distance divided by time, right? Because the units are meters per second. It's a good way of remembering what the formula is. Or kilometers per hour, then we have distance divided by time. So then we never forget this formula, distance and time. So then distance, we need to pass the time to the other side. So if we write this as v is equal to d over t, then if we pass the time multiplying to the other side, then we have tv equals d, or we multiplied both sides by t, is the same thing. And then the distance is the same thing as the time multiplied by the velocity, right? Time multiplied by the velocity. And if we look at our graph here, if this is our time, and this is assuming that it's a constant velocity, right? It could be not a constant velocity, but we'll talk about that in a second. So if this is a constant velocity, let's do it for here, right? Here's a constant speed of 30 meters per second. So 30 meters per second between 2 and 5 seconds means that our distance would be 30 meters per second times 1, 2, 3 seconds that it lasts for. So we have 3 seconds times the velocity, or times the speed, which is 30. So in other words, that would be 90 meters, right? And so that would be the distance traveled over this period, and that was easy because we have a constant speed. But what happens when you don't have a constant speed? Like here, from here to here, the speed is increasing. So there you need the average speed, and since it's a straight line, we can calculate it easily because it's changing at a constant rate. The average speed, if it starts at 0 and then it goes to 30, then the average speed would be equal to 0 plus 30 divided by 2. That's like calculating the mean, and that's 15 meters per second, right? So the average speed is 15 meters per second, which is around here in the middle. And then we can now use our time times the speed is equal to distance, and we can get that it will be time multiplied by the speed, which is equal to, how long does it take? 2 seconds. 2 seconds multiplied by our velocity, which is 15, and so that goes to 30 meters. So that's how much it travels in this time here, from here to there, and 90 meters is how much it travels from here to there. So you might have realized already, or you might know it from before, but basically what we're doing is to calculate the area of this graph. If you look at what we did here, we multiplied the full time, which is the base of this rectangle here, and we multiplied it by the increase in distance, by the increase in velocity, or well, we just multiplied it by the velocity during the time. So basically the velocity is the height of this rectangle and the time is the base. So by multiplying one by the other, we've just calculated the area, and that's given us the 90 meters. So we could write in here 90 meters for the area. That's what it travels there. And similarly here, in the second part, we did the average speed, so we had to divide by 2, but if you remember the formulas for your area of a triangle, the area of the triangle is the half of the base times the height. So where here we were doing the full base times the height, here we have to do the full base times the height divided by 2. So here we did it, we just did it in a slightly different way because we were averaging the speed. So we did 30 plus 0 plus 30 divided by 2, and then we multiplied it by the 2 of the time here, this 2, right? And this was already divided by 2. So in other words, we did the same thing as if we'd say, hey, straight away we're gonna get the area of this. What's the height? 30. What's the base? 2. So it's 30 times 2. What do we need to do? Divided by 2, because it's half of the base times the height. And so we would have got the same thing. 30 times 2 is 60. Divided by 2 is 30. And that would have given us the same thing as here, which we had was 30 meters. So hopefully that makes sense. So that's how we calculate the distance. So this would then be 30 meters. There. And that's how we calculate the distance from a velocity time graph. Okay, remember it's velocity time, because it's the velocity that if you multiply velocity times time, then you get the distance. And finally, the last part was how do we get the acceleration. And the acceleration is just going to be the inclination of these lines, so like the gradient. So what's the gradient for this part of the graph? Well, the gradient is 0 because it's flat, it's not increasing at all. So that makes sense because the velocity is the same. So if the velocity is the same all the time and the gradient is 0 all the time, then if we are saying that therefore the 0 acceleration, that makes perfect sense, because if the velocity is the same, then the velocity is not increasing at all. So we have a 0 acceleration. But here we have the velocity that it is increasing, and it's a straight line, so therefore we can calculate the gradient and calculate the acceleration. Let's see, what's the gradient? The gradient is the increase in the y-axis, in y, divided by the increase in the x direction, right? And here I'm saying increase in y divided by increase in x, but it would really, in this case, would be increase in v divided by increase in t. So in other words, the final velocity, which was our formula for acceleration from before. Final velocity minus the initial velocity will tell us the increase in the y-axis. Here is the v, and the divided by the increase in the x-axis, here increase in x, and that's increase here from 0 to 2. So 2. So that would be over time. So over time. So in this case, the acceleration would be final velocity, which is 30, minus the initial velocity, which is 0, divided by 2, and that gives us 15 meters per second So meters per second squared. So that would be our acceleration. So then in order to find, so just a quick recap, in order to find the speed, we just read it off from the graph. Here we read it off the y value from the for the appropriate time that they ask us for. In order to find the distance, we find the area, and in order to find the acceleration, we look at the gradient. So in other words, we can say here that for vt versus, we often say versus here, v versus time, or vt graph. For a vt graph, speed, we just read it off the axis at the time that we're interested in. The distance, we calculate the area under the graph. It could be under a triangle, and then we do half base times height, or it could be a rectangle, nice and easy, and then we just do base times height. Right, and then if we wanted the acceleration, then we need the gradient. Alright, so if you notice, the gradient of a VT graph gives us the acceleration, gives us the acceleration. But the gradient of a distance time graph, the gradient of a distance time graph, the gradient here gave us if the gradient is increasing, that's the speed. That's what it was giving us. And when it's not increasing, it's gradient 0, so speed is 0. Right? Because the distance away is not changing. The distance is not changing. So the gradient here in a distance time graph, gradient is equal to speed. But here we've been talking about velocity time graphs, and in velocity time graphs the gradient is equal to the acceleration, right? If the gradient is 0 on a velocity time graph, this means the velocity is not changing, so therefore it's still traveling, the distance would be moving, distance would be changing, but the acceleration would be 0 because the velocity is always the same. So just as a last thing, so we see that there's different things. If this is a distance time graph like we were talking about before, and this is a velocity time graph, then a line that here looks like this, where there is a constant increase in distance with time, that means constant velocity, and here it would look like a constant velocity, so the velocity is not changing with time, so these would be equivalent. Okay, if the gradient, and then here if the value here is 20 meters per second, right, then here the gradient would have to be equal to 20 and then the value would be 20 meters per second, right? So this inclination, i.e. the y divided by the x, would have to equal 20. Hopefully that makes sense. Then if the velocity here was 0, then here it would look like this. The velocity is 0, the distance doesn't change, so it would just be the same distance all the time, and here it would just be 0 velocity. As time goes on, 0 velocity. Okay, hopefully that makes a bit of sense. See you in the next video.